Exponential functions and graphs of exponential functions. The definition of an exponential function is that it is any function of the form y equals a number a times b to the x power, where a cannot equal 0, b is greater than 0, and b cannot equal 1. Also, x is any real number. So x is going to be our variable that we can change. A and b are constants. So they will always be the same number, and then you change x. Alright, so that is how we will be writing our exponential functions. There are other ways to write it. We might also say y equals f of x, because we know that's true, function notation. So we could say f of x equals a times b to the x power. It means the same thing. We're just going to be putting the x in. Okay? We might also say y equals a times b to the x power. We may also write it like that. So there are a couple different ways that we can write it. The key thing to remember is a function is exponential if there is a common ratio between the y values. So to see if it's exponential, you need to divide the y values to see if it's the same with each one. So let's look at some common exponential graphs. The first type of graph is if we have y equals a to the x power, where a is just a whole number. So in these graphs, we're going to cross at 1 on the y-axis, and then we're going to go low on the left, and then it's going to rise as we go up to the right. So that is if a is a whole number. Alright, now the next option is y equals negative a. So if our a is a negative whole number, then our graph is going to cross at -1 right here, and then it's going to be close to my axis, and then it's going to rise and come up like that, or go down like that rather. Okay, so if it's a negative number, it's got to point down. We also have the possibility of having fractions. So this next one, we have y equals 1 over b. To the x power. Okay, so this one, we're going to be crossing at 1. That's the common thing. It always crosses at 1. It's going to be high on the left, and it's going to come down. It's never going to cross the x-axis. So if, b is a fraction, that is less than 1, then it's going to look like that. And my last option is if the b, the thing inside, is a negative fraction. Okay, so in this case, we have y equals -1 over b to the x power. So if I were to graph that, it's going to start really, really low, and then come up and go through 1, and then get closer and closer to my axis. try that again. So that is if we have a negative fraction inside the parentheses. In these next examples, we want to tell if the situation is going to be exponential or not exponential, and then explain why. So in this first example, we want to note that each of the x values are increasing by 1. Okay, so once we know that they're all increasing by 1, then we can assess our y values. So we want there to be a common ratio. Well, that would be a common fraction. They mean the same thing, ratio or fraction. Same idea. So what we're going to do here is we're going to look at our y values, and then we're going to go -3 divided by -1. And then see if that is the same. Is that the same as -9 over -3? And is that the same as -27 over -9? Okay, so if we simplified all of these, we would get double negative changes to a +3 equals double negative changes to +9 divided by 3 is 3, which equals 27 divided by 9, which is also 3. So yes, there is a common ratio of 3. So that means that it is exponential. So we would just say yes, the table demonstrates an exponential function because there is a common ratio of 3. Now this next one, when we're looking at it, we're going to look at our equation. We have y equals 3 times x squared. Okay, now an exponential function has to be y equals a times my b, which is a number, to the x power. Since the x is not in the exponent, it's not exponential. So the function is not exponential because the x is not in the exponent. In these next two examples, we're going to evaluate the exponential function. So suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function that we're going to use is f of x equals 30 times 2 to the x power, and that gives the population after x weeks. How many beetles will be in the bin after 56 days? So the first thing is we need to convert days to weeks because x is weeks. Alright, so to take days to weeks, we need to go 56 days. And we're going to multiply that times. We know there's 7 days in a week. 7 days per 1 week. So my days cancel out, leaving me with 56 divided by 7. So we have 8 weeks. So I'm going to put in 8 for x. So I'm finding f of 8. So that would be 30 times 2 to the 8th power. We're going to take that x and put it in for... So when you type it in the calculator, type it as 30 parentheses 2 parentheses caret 8. And then you would get 7,680 beetles after 8 weeks. The next one, we have an initial population of 20 rabbits that triples every half of a year. The function f of x equals 20 times 3 to the x power is going to give the population after x half-year periods. How many rabbits will there be after 3 years? So you have to convert years to half years. Alright, so that would make, in 3 years, there would be 6 half years. Okay, so I'm going to put in x equals 6. So my equation, f equals 20 times 3, and I'm going to go 6, and then I type it in exactly as I see it, 20 parentheses 3 end parentheses caret 6. So I would get 14,580 rabbits. And that's your final answer. In this last example, we're going to graph the exponential function. So to graph the exponential function, we've already done stuff like this where we just put in x. So for this first one, my y is going to equal 3 times 2 to the negative 2 power. So I'm going to type that into the calculator and I get 0.75. So my point that I graph would be a negative 2 on my x and a 0.75 on my y. So that would be negative 2 at 0.75, which would be about right there. And then I go on to the next one. Y equals 3 times 2 to the negative 1 power, and that's going to give me a positive 1.5. So I'm going to have negative 1.5. So at negative 1, I'm at 1.5, which would be right here. And then the next one, y equals 3 times 2 to the 0 power is going to give me a 3. So that is at 0, 3. So 0, 3 is right here. And then I put in 1. Y equals 3 times 2 to the first power is going to equal 6. So that is the 0.16. 1.6. And then the last one I have here, y equals 3 times 2 to the second power. And that's going to give me a 12. So that is the 0.212. So at 2, 9, 10, 11, 12. Somewhere about there. And then I connect my points. And I can kind of see that it's not a straight line, it curves, and it goes up like that. So it looks like an exponential function. And that would be your final answer. So those are your notes over exponential functions and how to graph them. Go through some practice problems. Make sure you can do all of these from identifying the function, evaluating the function, and graphing the function. And then you should be able to take your quiz over this material.